So today we'll start a new chapter that is on probability, because in class 12 you have Bayes theorem. Okay, so to understand Bayes theorem, we have to go to class 11 and understand the basics of probability first. Then once we understand the basics of probability, then we will go to Bayes theorem. Without understanding basics of probability, we cannot understand Bayes theorem. So we have to go back to class 11 probability, and then from there we will go into Bayes theorem. Okay. So there are certain what I will say, there are certain terms that you need to be familiar with for doing numericals on probability. Okay. So one is called a random experiment. Okay. A random experiment. Okay. So what is a random experiment? So a experiment is called random experiment if it satisfies the following two conditions. Okay. It has more than one possible outcome. So one is it has more than one possible outcome. An experiment is called random experiment only if it has more than one possible outcome, and the second condition is it is not possible to predict the outcome in advance. It is not possible to predict the outcome in advance. If these are the two conditions which are satisfied, then it is called a random experiment. Okay. So, in our day-to-day life, we perform many activities which have a fixed result, no matter any number of times they are repeated. For example, given any triangle, without knowing the three angles, we can definitely say that the sum of measure of angle is 180. So there are certain things in day-to-day life which are outcome is fixed, but there are certain things where the outcome is not fixed. Okay. We also perform many experimental activities where the results may not be same when they are repeated under identical conditions. For example, when we toss a coin. Okay. So when a coin is tossed, the so the example of a random experiment is tossing a coin. Okay. Tossing a coin. Okay. Why it is random? Because it has more than one possible outcome. It can either be head or it can be tail also. So it has more than one possible outcome, and when we are tossing the coin, we are not sure whether head will come or tail will come. So tossing a coin is a random experiment. Similarly, like throwing a dice. Okay? Throwing dice, right? So you are not sure whether one will come or two will come or three will come or four will come or five will come or six will come. So these are some of the examples where you are not sure about the possible outcome. It is more than one outcome. It is not possible to predict. Also, it has more than one outcome. So when these two conditions are satisfied, these examples are random experiment. Okay. So then there is another term which is called outcome and sample space. So this is random experiment. Then another thing is called outcome and sample space. sample space. Okay. So what is a sample space? Okay. So a possible result of a random experiment is called outcome. So let us say head is an outcome, tail is an outcome, 1 to 6 is, so these are all outcomes. Okay. So these are the possible results. So results is called, so outcome is nothing but your result. What you get is outcome. Okay. So that is your result is called outcome. So consider the experiment of rolling a die or throwing a die. So the outcome of the experiments are 1, 2, 3, 4, 5 and 6. So if we are interested in the number of dots on the upper face of the die, okay. So the set of outcome, so here what is sample space? When you are rolling a die, your sample space is nothing but your 1, 2, 3, 4, 5, 6. So this is your sample space when you are rolling a die. Okay. And similarly, when you are throwing a coin, your sample space is
head and tail.
Okay. So sample space is given a symbol S. So sample space is written as S. Okay. This is the symbol of sample space. Okay. So each element of a sample space is called sample point. So this is your sample space here, and each element of the sample space like 1, 2, 3, 4, 5 is called sample point. Okay. Another terminology, sample point. So each outcome in a sample space is called a sample point. It is called sample point. In other words, each outcome of the random experiment is also called sample point. So these outcomes are also sample point. Okay. Now let us consider one example. Okay. So now we understood. We have come across these terms now. What is random experiment? So random experiment is something like tossing a coin or rolling a die. These are random experiment where the outcomes are more than one. In one case the outcomes are 2, in another case outcomes are 6. And also it is unpredictable. You don't know whether 1 will come or 2 will come or 3 will. So we know now what is random experiment, what is outcome, what is sample space, what is sample point. So this up to this we are clear now. Okay. Now we will do some example. So random experiment, sample space, sample point and outcome. So these are few terminology. Those are related to theory of probability. Okay. So these are some terminology. So that's why when something is not predictable, there we say what will be the probability. Okay. We say when something you cannot predict, then you use the theory of probability. Okay. So let us solve one example. So 2 coins, a 1 rupee coin and a 2 rupee coin are tossed once. Okay. Find the sample space. Okay. So a 1 rupee coin and a 2 rupee coin are tossed once. Okay. So when you are tossing a 1 rupee coin and 2 rupee coin once, what will be the sample space? Clearly the coins are distinguishable in the sense that we can speak of the first coin and the second coin. Since either coin can turn up head or tail, the possible outcomes may be like, so you are tossing once only. Okay. So you have tossed, let us say the 1 rupee coin. So let us say you have a 1 rupee coin and let us say you have a 2 rupee coin. So you have you can toss 1 rupee and 2 rupee coin only once. Okay. So the what can be the sample space? The sample space can be, let us say this is H and the second coin also H. So this is one sample space, like H. This is one sample space because you are just throwing it one. Okay. So point. You can have head on both coins. Similarly, you can have head tail. You can have tail head.
Tail.
And tail. So these are your head on the first coin and tail on both coins. So thus the sample space. So this complete thing is one sample space.
Each is sample.
So actually this is not a sample space.
This
is the outcome. See, earlier we were tossing one coin. That time the outcome, when you were tossing one coin, the outcome was
sample point. That head.
So when you were tossing one coin, what was happening? When you were tossing one coin twice, okay, one coin twice, okay. So first can be head, second can be tail. That's all. One coin twice. So it can be head, tail,
or tail.
No, one coin twice also.
All these four can
same. Have. Two coin once or one coin twice is the same, right? Same thing. Sample space is same. But if you are tossing it once, it will be tail or head. If you are tossing it once, this is the sample space.
Yes.
If you are tossing the dice once, this is the sample space. Right? If you are tossing once, right?
Yes.
This is the sample space.
Yes.
But if you are tossing a 1 rupee or 2 rupee, 2 rupee, so your sample space will be like 1 rupee and 2 rupee once. Okay? So your sample space will be this. So there are four outcomes. Okay? So it can be HH, HT, TH and TT. So your sample space S is equal to this.
Yes.
Okay, so whether you toss one coin twice or two coin once, this is the sample space. But if you are tossing it once, this is the sample space. Okay. So the outcomes of these expressions are ordered as pairs. So this is pairs. Okay. When you are tossing twice one coin or tossing once two coins, this is ordered as pair. That is the sample space. Okay. As for the sake of simplicity, the commas are omitted from the ordered pairs. So for sake of simplicity, you are omitting the commas there. So this is the sample space. Okay. So the outcome of this experiments are ordered in pair. For the sake, okay. So this is one example we have got. Okay. So now we will solve one other example. Okay. So let us say this is example 1. Okay. So let us solve another example, that is example 2. Okay. So what is the example? Find the sample space associated with experiment of rolling a pair of dice. Okay. One is blue and other is red. Also find the number of elements of this sample space. So the experiment is find the sample space associated with experiment of rolling a pair of dice. Okay. Rolling a pair of dice. Okay. So two dice. Okay. So you are rolling two dice once only. Okay. You are rolling two dice only once. Okay. Find the number of elements of this sample space. Suppose, so it will be like what will happen? Like, okay, so it will be like the sample space will be something like this. See, first one will be 1, second one will be 1. Okay. Then like you can put a comma here. 1, 1. Okay. Then 1, 2. Okay. 1, 3. 1, 4. 1, 5. 1, 5. 1, 6. Like this. So there are 6. Okay. Like that it will become 2 1 2 2 6.
So 36.
2 6. So like that it will go on as 6 1. Then it will go to 6 6. So it will be like this. So here in the row, in the column you have 6 column, and now you have 6 rows.
6 rows.
So it will have 6 into 6, that is 36 elements. 36 elements. So your sample space has 36 elements here. Okay, so these are some of the example how for a coin tossed once, coin tossed twice, or two dice rolled once. So what will be the sample space? That, so now we have understood what is sample space. Okay, so there will be some. So there are some exercise on this finding the sample space. You can solve this. Okay. So now we have gone up to like say section 16.2. So now we will go to section 16.3, which is event. Okay. So till now you are clear.
Yes.
I am repeating it. I have taught it you once, but probability is not very simple or straightforward. So we need to repeat it, practice it to understand it, because once studying, it is not necessary that you can digest it completely. Okay. So if you repeatedly study it, it will be easier for you to understand. Okay. So now we have discussed about the sample space, random experiment, and then we have discussed about the outcome. All these things we have discussed. Okay. So now by tossing two coins once, or one coins two coin once, or tossing only one coin, what will be the sample space, and tossing two coins, like first one is HT is tossing two coins once. Okay.
Then one
This
coin
one
twice.
is
One coin once.
one coin once. One coin once. So one coin once.
Two.
This one is two coin once or one coin twice. Okay. So so now we'll get to the concept of. We'll get to the concept of something called events and all that. Okay. So we'll get into that events. What is a event? Okay. In section 16.3 in your book. Okay. Event. Okay. Another terminology in probability is event. Okay. What is a event? Okay. So okay. So we have studied above random experiment sample space associated with the experiment. The sample space serves as an universal set for all the questions concerned with the experiment. Consider the experiment tossing a coin two times, and associated sample space is HH, HT, TH, TT. Now suppose that we are interested in those outcomes which correspond to occurrence of exactly one head. Okay. So now we have tossed one coin twice or two coin once. So we have got our sample space as HH, HT, TH and TT. Okay. So now we want a event. So there is one event. Now suppose that there is a event. There is which corresponds to occurrence of exactly one head. Okay. So we want the event is occurrence of exactly one head. Okay. So this is our question now. Okay. Occurrence of exactly one head. Okay. So so you can see here now which is having exactly one head. So this is one head, this is also exactly one head. Okay. So there are two events where you have exactly one head. Okay. So so those two events are otherwise called as E. Okay. So here E is equal to HT and TH. Okay. So here event is so the event is HT and TH. Okay. So let us see. So okay, this is fine. Okay. So HT and TH. Okay. So this is an event having. So you know now what is S and what is E. One is sample space, another is event. So so you have a event which has occurrence of exactly one head. So these are the two, 1 and 2, these are the two events. So there are 4 events here. So you can call it as sample points also, you can call it a event also. Okay, so then, so now you have, we know that the set E is a subset of sample space. So you know now E is a, so you
Subset
have seen a subset, I think this is the formula, no? This is the symbol.
For subset, yes.
So now event is a subset of the sample space. Okay. Similarly, we find following correspondence between events and so events and subsets of S. Okay. So okay. So so there can be multiple events here. Okay. So where like say number of, let us say number of tails is exactly 2. Exactly 2. This is one event. Okay. So what is that? That event, let us say the name of the event is A. Okay, that is TT only, right?
Yes.
Okay, so there is another, can be say number of tails is at least 1. So number of tail is at least 1. At least 1. Okay. So let us say this is B. So tail at least 1 means how much? This and this. There are 3. Okay. So that is nothing but your HT, TH and TT. Right. So now you know this is your event where this one. So now like this you can get, like there are number of head is at most 1. Second toss is not head. So second toss is not head. So here you can see this one and this one. Second is not head. So there are 2. So HT and TT. Second toss is not head.
It's tail.
And number of tails is at most 2. So number of tail is at most 2. So everything.
All of them.
Everything. 0 to, that means 0 to 2. At most 2 means what? 0 to 2. So all of them. Okay. So now you understand what are the events. Okay. And event, any event, any subset E of a sample space is called event. Okay. So any subset of a sample space is called an event. So subset of a sample space. So these are all subset of a sample space is called an event. So earlier we were telling only this one was sample point, 1 point. But a combination of sample point which is a subset of sample space is called an event. Combination of sample point which is a subset of a sample space is called an event. So event can have multiple points, but it will be subset of a sample space. Okay. So now you understand difference between outcome, sample point and event. Okay. So okay. So there are different types of events that we can come across. There can be different types of event. Okay, so there is types of event: impossible event or sure event. Okay, so the empty set phi and this sample space describe the events. In fact, phi is called impossible event. So nothing will happen.
Impossible.
That is impossible. So phi is an impossible event. Impossible event, and S is the whole sample space is called a sure event. Okay. To understand this, let us consider experiment of rolling a die. So now you can, these are theoretical part. This is impossible and sure event. There are some other terms which are let us say called simple event. Okay. So we have, there is impossible and a sure event. Okay, impossible phi is a impossible. Okay, that you can read. Okay, impossible and sure event. There are some other event with another thing which is called a simple event. Okay, simple event. Okay, so what is a simple event? Okay, so if an event E has only one sample point of a sample set, it is called a simple event. So like if it has only one sample point, that is a simple event. Okay, so that is the, like say HH, HT, TH, T8, TT. These are called, like say E1, E2, E3, E4. These are called a simple event if E1 is only HH. Say. Okay, if E2 is only HT, if E3 is only TH, if E4 is only TT. That means these are simple event. Okay, simple event will have only one sample point. Okay, so that is called a simple event. Okay, then what is a compound event? If an event has more than one sample point, it is called a compound event. So this here A is a simple event, whereas B is compound event. Okay, so now you understand what is simple event and compound event. Okay, then algebra of event. So in the chapter on sets, we have studied about different ways of combining two or more sets, like union, intersection, difference, and complement of sets, etc. So likewise, we can combine two or more events by using the analogous set analogy. Okay, so where you can combine it. You can find the intersection of it, union. Or you can find the union. So you can find the union, intersection. Intersection is the common between two events. Okay. So suppose you have two combined events. To find the intersection, you will find what is the common between the two. So that is the intersection. Similarly, difference and complement and all that you can find using the set analogy. Okay. So you know the difference between A or B. So if or means union. Yeah. Okay. And if you want to find A and B, that means it is the intersection. Okay. And A not B. A not B means a minus. Okay. That is the difference. So A but not B. That means A minus B. So and or, so you have and means A intersection B, right?
Yes.
Or means A union B, and A not B. A not B means that is A minus B. Okay, so now you understand A union B, A intersection B, A not B. Okay. A but not B. A but not B means A minus B. Okay. So which A minus B is otherwise called as A intersection B dash. That you can find out. Okay. That is the task for you. Okay, so that is obvious. Okay,
Yeah.
so and there is a minus b. That so these things you can easily do. Okay, I am not going into the details of it. Okay, then there is something called mutually exclusive event. Okay, so if in the experiment of rolling a die, a sample space is 1, 2, 3, 4, 5, 6. So consider event A an odd number appears and B an even number appears. Okay. So when you are throwing a die, one die you have thrown. Okay. So once. Okay. So the sample space is 1, 2, 3, 4, 5, 6. Right.
Yes.
So one event here, one compound event is even number. Okay, so even number means 2, 4, 6. So this is one event A, right? This is a compound event, right?
Yes. Yes.
A. So another event is like say odd number, right? 1, 3, 5.
Hi.
That means these are mutually exclusive. So clearly the event A excludes the event B and vice versa. So
Yes.
in other words, there is
No
no outcome
connection.
which ensures the occurrence of. In other words, there is no outcome which ensures the occurrence of event A and B simultaneously.
There is no dependence on each other.
So A and B are
Independent
mutually
of each other.
exclusive. Okay. So clearly, so when it is mutually exclusive, when there is no intersection between them. So if
There is
A
nothing
intersection B is null, then that is called mutually exclusive.
Exclusive event.
So now you understand what is mutually exclusive. Okay. Then there is something called so this is when this is mutually exclusive. So this is mutually exclusive. Clear?
Yes.
So now there is another thing which is called the exhaustive events. Okay. So consider the experiment of throwing a die. We have sample size 1, 2, 3, 4, 5, 6. So let us define the following events. So A number less than 4 appears. B number between 2 but less than 5. Okay. C a number greater than 4 appears. So when you combine all these things, you will find the sample space. Okay. So the combination of these events, if it gives a sample space, that is called exhaustive event. So if you have events, say let us say E1, E2, E3, E4 like that. Okay. So the combination of E1, E2, E3, E4. So this combination, if it is the sample space, then it is called an exhaustive. This is the exhaustive event. So the combination of all these events, if it give rise to sample spaces,
It's
so
called exhaustive.
so consider the experiment of throwing a die. We have a sample. Let us find the following event. So then, so in that case, this event E1, E2, E3, E4, each of them are called exhaustive event because union of all four gives rise to sample space. If that happens, then that is called, these events are called exhaustive events. Okay. Okay, so now you understand what are exhaustive event, what are mutually exclusive event, and you have understood what is a simple event, what is a compound event. So only one sample point is simple, more than one sample point is compound, and you know what is union, what is and, what is the meaning of or, what is the meaning of A minus B. That means A but not B. Okay. So now you understand all those terminology. Okay. Now with after understanding all this terminology, we will calculate different probability. Okay. So next will come the calculation of probability. Okay. So now we understand on a whole like the concept, the groundwork for the probability. Now next will come the calculation of probability. Okay. So just to give an example, suppose you are you are tossing a die. Okay, so rolling a die. So 1, 2, 3, 4, 5, 6. So the probability of getting 1 is how much? 1 by 6. Okay. So the event
Is getting one.
The number of elements in the event, right? So
Event is getting one.
event is getting 1.
Sample
that-
space is
हाँ,
1 to 6.
1 to sample space, so 1 by 6. Okay. What is the probability of getting 1?
1 out of
So event is getting 1. Okay. So that how much it is? 1.
1.
Okay. How many items are there in the event 1? Only 1. Okay. So that 1 by 6 is the probability. So in the next session we will do something on probability, some examples on probability, and then we will get into conditional
Base.
probability, and then we will do
Base.
the Bayes theorem. Okay. Next session we will do. Okay.